Our app worked perfectly fine before our change, and as far as the user can tell, there is no difference. So what is the real benefit of dependency injection? Going back to the first version of our view model, where it creates an instance of the counter dependency, we can create a unit test for this that passes. The test seems simple and logical. We're keeping track of the last emitted value, calling add clicked on our view model, and verifying that the last emitted value is what we expect. When we run this test, it passes. Now if we change the single step counter to start at 1 instead of 0, what would happen? This same unit test fails. This failure is not valuable because the functionality of the view model has not changed. Now we need to update our unit test to account for an implementation detail of the counter dependency. This sort of churn can lead to wasted developer time and a loss of trust in your app's test suite. Going back to our view model that uses dependency injection. In our test, we can create a fake counter implementation. When we use that in our test, we are validating the functionality of the view model, which is the goal of the unit test. No change in counter implementations can break this unit test. The main point to take away for why we use dependency injection is that it allows us to create and validate objects that won't break if implementations of dependencies are changed. This allows for more resilient unit tests and increases reusability of objects. For example, another view in this app could use the same view model with a different counter implementation. With an app this simple, it's hard to grasp the full benefits of dependency injection. We'll be building a more realistic app in the upcoming lessons, which should help drive those benefits home.